Hello, hello, and welcome to the Cloud Show. This is your host, Magnus, speaking again. And this week we have an very interesting topic. We're going to discuss how is cloud native development, developing applications that are supposed to run in the cloud, how is that even different at all from whatever we have been doing so far before we were using a cloud platform? And what kind of new challenges does this impose on our organization? So another hot topic today on the Cloud Show, and this day we're going to be talking to my good friend Alex Mang. Hello, Mr. Mang.
Hello, Magnus. It's so good to see you again.
Yeah, brilliant to see you. And I'm so happy that you're on the show today. So you are based out of Romania, and that's where you're doing is this your office?
This is my office. A lot of your viewers may actually recognize this office back in the days when I did a bunch of recordings for the Cosmos DB series, which is still available on YouTube. This is my office. This is in the backwoods of Transylvania specifically. That's an actual place.
Yeah, it's an actual place. It's not only in the movies.
It's not only in the movies.
All right, brilliant. So, and you have been a cloud consultant. Your business has been consulting with companies about cloud for a long time, many years.
I think that's the easiest and shortest way to put it, and that is correct. I still think of myself as a software developer at heart. I still write a lot of code on a daily basis. But in all fairness, I've mostly been doing cloud architecture and cloud consulting in terms of security and writing better, scalable, more reliable software, specifically the software that is going to run in the cloud. So those greenfield applications, right? The applications that you develop from ground up, which know you're going to deploy in the cloud. That's what I've been focusing on over the past decade or so.
Brilliant. And that's a good topic to dive into, and that's what we're going to do right now, because we have all these promises that going to the cloud is going to be cheaper, it's going to be more secure, it's going to be more agile, it's going to be more scalable, and so forth. Brilliant. Yes, wonderful. We're going to use cloud services. Okay, cool. So what does that mean for the applications that we are developing? How is it different from not using a cloud platform?
That is a fantastic question, because when I started working with the cloud, which is literally when Azure was still a baby, they called it Windows Azure back then. Exactly. That was like 2010 or so. And there was a lot of promise and even expectation to an extent that if you'd run your app in the cloud, it would magically be more performant, more scalable, more secure. Well, some things might be true, but not to the extent that they might have been marketed, in all fairness, right? So if an application doesn't run as it should on premises, in all fairness, it will probably not run as it should in the cloud. But on the other way, if you have developed a very performant application on-prem and then you try to migrate it over to cloud lift and shift, that works. The problem, however, not necessarily a problem, but the downfall of that approach is that you might stop your development process and your efforts at that stage, and you're not actually taking advantage of the cloud. You're just using somebody else's computer.
Right. That makes sense. So now that we are using somebody else's computer, we're running our application in the cloud. It also means that rather than running things on a server, which we are accustomed to, where we would be storing files on a hard drive, or even using a database server right next to our web server. That was literally how we built applications pre-cloud. Like we had two server blades, right, in a rack, and a piece of cable this long that connects the two, right? Literally, that's how it was done. And nothing wrong with that. That worked very well. And then the cloud came with other promises, and now we might be using a database service or a file storage service, which is no longer in our complete control. It is a service. What does that mean for how we are working with them in terms of development?
Fantastic question. So the fact that you emphasize the word service, right? A lot of marketing people do that as well, as a service, right? Magnus as a service, if you may. Anything as a service.
The best service.
That's the entire thing. You want to take advantage of the cloud, not necessarily as a piece of software or hardware that somebody else runs, but rather as a commodity service that you're taking advantage and you're paying as your business grows. And that's literally what the cloud should be all about. The holy grail of the cloud is that you're exactly paying for what you're consuming and nothing more. And the moment you stop consuming it or you consume it less, you're going to pay less. But you invest a lot in the actual business logic and the business value that you add to your customers. So your customers are constantly going to get new updates, new features, more secure apps, more reliable apps from yourself as a developer, rather than them paying for you to upgrade your processor, change your HDDs to SSDs and whatnot, right? That's so old. It's so old school. That's what my father used to do 3 or 4 decades ago.
Absolutely. And so now, as a developer, I'm sitting down. So I'm going to write some code. I'm going to start using these other services that we are now using and consuming and paying for as we go. What do I need to think about now? Because I know that back in the beginning, Microsoft were trying to teach us cloud patterns for coding, for connecting to remote services, and those were kind of a novelty for us back in the day, right? But what's different here?
They were definitely a novelty, and in all fairness, those among us who still remember when we would walk into a room and we would talk about command and query responsibility segregation, everybody would just shush, right? And then they would listen in and stuff like that. That's amazing. But the reality is that in today's world, I don't believe that learning a single programming language still works. It's almost inevitable that your application or part of it is going to run in the cloud. And therefore, you should be open-minded towards learning about the new services, which may or may not, but most of the times do offer more flexibility, more competitive pricing for the services that you'd otherwise host yourself. Now, the problem with that approach is that you either fall into the pit of learning a lot of new technologies and working against a lot of new technologies and inevitably being what they call vendor locked in. Or alternatively, you think about abstractions and abstraction layers, which somehow enforce you to be a better developer. For the past 3 decades, at least, we've been talking about design patterns which haven't been thought about in the terms of the cloud because there was no cloud back then. We were mostly considering what we would refer to as distributed computing. Some of us must remember that. There's even the fallacies of distributed computing, such as the network is homogeneous. There's only one admin. There's no boundary. There's infinite connectivity and stuff like that, right?
Right.
That's such a shortfall, right? But in all fairness, when you go into the cloud, and you might remember, Magnus, there were not only design patterns, but there were also indications that you should expect, for instance, failures to happen because you're working across the network. So implementing things such as transient error handling is imposed. Now, if you're a brand new developer today, some of these may no longer be your concern because the clients, which are super smart, the SDKs that have been developed by the various vendors out there, they already, to an extent, handle that. The problem, however, is that if you still start with the mindset of n-layer architectures, 3-layer architectures with the web and the API and the database beneath that, you're not literally using the cloud, right? And therefore, things such as what they refer to as cloud native, where you're focusing on your processes as microservices, as actors and whatnot, they scale with your actual consumption. And therefore, we head back to the Holy Grail, which I talked about previously. You actually pay for what you consume. So the idea is figure out the services that you want without having to spend all of your time studying, researching, and learning about those technologies because they might be obsolete next year. So the moment you learn about technologies, make sure that you also learn about abstraction layers and figure out how many of those abstraction layers actually overlap with design patterns that have been taught and lectured for probably 3 or 4 or even more decades.
Right. I mean, it sounds a lot like you are saying that the newness of the cloud can sort of be contained. It can be managed by just using many of the same old architectural paradigms that we should have been taught in school.
Yeah, I agree entirely. I remember when we were still doing back in the day tenders, in Eastern Europe and Central Europe, when they would even suggest that you should use some sort of a relational database for your application, right? That was a requirement from the customer.
Yep.
That's such a big no-go these days, right? Because you want to use what they call polyglot persistency, which effectively means you're going to use a lot of different languages, polyglot, right, from the Greek words. And that imposes that you're going to use both relational, non-relational databases. Non-relational can be document databases. They can be key value pairs, graphs, and whatever else, whatever
the right
fits
tool
the
for the
needs
right
of your
job,
apps.
right?
Yeah, exactly. The right tool for the right job. You could use a hammer for anything.
Yeah,
but
sure.
It's not the greatest tool for example, for twisting wires together.
And we've all been there where somebody thinks it's a good idea to maybe store. I mean, we're storing all the other data in the database, so why not store a little binary as the bio picture of the same person and put that binary in the database? That's a good idea, right? No, it's not. It's a terrible idea. Don't ever do that.
But this did it, and some might still do it today, right?
Yeah, exactly.
Because they don't know better, and that's why we're here. We're here to tell them that there's a better way. And in all fairness, even though
so as a company, so we're a company now. We're a business, and we're going to be using the cloud. So we want to ensure that this is an optimal approach, that we understand things. You indicated that first we need to figure out which services to use, and there's a lot of services out there. How the heck do we even know what to do here?
And there's a lot of vendors out there as well, right?
Oh, yeah.
Don't forget about that.
Of course.
I mean, you could double down on Microsoft, but there might be this one piece of tech coming from a different vendor, say from Amazon, from Google, or from whoever else. We don't know what the next big cloud is going to be.
And or some messaging service or whatnot, right? That we might want.
There might be a fantastic third API that you want to take advantage of. Now, inevitably, you're going to fall into this mistake that you are just going to focus on a single piece of tech. You're going to install their NuGet packages. You're going to install their SDKs and their libraries, and then you're locked in. Now, rather than doing that, an alternative would be to take advantage of yet another design pattern, which is these sidecars that we've been talking about ever since the days of Kubernetes, where one container is your app and another container running within your pod is just something that supports your app, and we call that a sidecar. Now, you can have communication between your apps for microservices, but you can have logging as well, which could therefore be some sort of a telemetry sync for, say, application insights or Azure Monitor or whatever else have you, Splunk, or you name it, right? You might as well have a different piece of technology running alongside with your app in order to monitor performance counters, or maybe to offer you some sort of persistency layer and so forth. There's so many different examples, but the idea today is that if you design your application to focus specifically on one single responsibility, right, and think about the single responsibility pattern whilst you're designing your application, and you bring up a lot of different projects in Visual Studio, if you may, each one with its own single responsibility and with its own API endpoints, you end up with something that is massively scalable and can also be deployed to customers in its various customizations and combinations. We at some point work with the customer who will literally develop an application just like a car configurator from whatever brand you want. I'm sure, Magnus, you've probably configured your car once on Toyota, BMW, it doesn't really matter, right? And you went there and you selected, almost like with McDonald's, you selected, I want a piece of that and I want to have some extra of that, right? And then that's your app, that's your car. We have a customer who literally did that. They have a bunch of microservices, and then they're deploying, they're just saying, I want to have a Big Mac with some extra fries and a Diet Coke, right?
And a pizza.
And a pizza, of course. And that's so cool.
Yeah, absolutely. And that makes sense. So with that comes, of course, the flexibility or the liberation. First of all, you don't have to know inside of your business code the business code of your app was what I was going to say. You don't have to know exactly how does the storage really work. It shouldn't be a concern. Those details shouldn't bleed into your business logic, because now you have tied business logic that you have invested tons into. You have tied that to a specific technology, and that's kind of a no-no.
It definitely is. Now, there is some resemblance that some of us might recognize from 2 or 3 decades ago, when there was this one banking application which was still running from 2 decades ago, which was developed back when by one developer in COBOL who's no longer with the company, and now we just don't touch that because nobody knows, right? It feels like we're doing that mistake again, where we're developing a microservice and then we're not touching it for a period because it just works magically, and then we might get back to it, but we don't want to touch or mingle with it because, well, nobody knows what's going to happen.
Nobody knows what the heck Alex did back then.
Well, Alex and God knew, but today only God knows, right?
Right.
The idea, however, is that the moment you start developing cloud native APIs and you focus on protocols such as HTTP or gRPC and whatnot, you actually work against some contracts. And if you focus on the single responsibility pattern, which is not something they did back then when they were using Fortran, COBOL, you name it, they were still developing monolithic applications. Right now, we're focusing on microservices, so single responsibilities. There might just be a single API endpoint. There might be 50, doesn't really matter. But it's just one thing with one domain, which has probably a bunch of experts in the company. But there's just one domain. The idea is that that should be replaceable because you have focused on the business logic rather than the boilerplate code written underneath the hood, which was having a bunch of strong dependencies on .NET Framework, God knows what, a version 2.0 or something like that, which cannot be installed on Windows 11, right?
Yeah, that makes sense. And so as developers in this space, we can do it any old way. We can still run servers in the cloud and still migrate the same and use the same coding principles as we did before. Technically, it's not the greatest of ideas. We could go we could go a step further and start to really start using the cloud native application services, cloud native services like storage services and so forth. But the sort of the evolution of that is to contain various concerns in such a way that we could even replace them, right? I mean, if
those concerns, if I may, those concerns actually even extend further, not only to the choice of the technologies and the services or the programming language, but even to the choice of the tools and the services you're using for ensuring faster deployments to your customer. Today's developer, which is extremely different from the developer back 10 years ago, today's developer not only develops code, but he maintains code. He keeps constant communication with his peers. He knows how to push code, which is going to be validated through a bunch of different gates and whatnot, which probably or ideally are automated. And at some point, his code is going to be very quickly validated whether or not it is ready for production. And whereas back in the day, the process would be, I'm writing something, I'm compiling it, I'm throwing it against the wall, and then somebody else is responsible for checking if it is installable to begin with, and then second, if it is secure enough or not. And then mostly because of time pressure, just going to deploy it and then see what happens, right? That is no longer the case today. We're focusing so much on security, reliability, availability and resiliency of the overall architecture that today's developer has to know to an extent some DevOps, some Ansible, some ARM, Bicep, Terraform, you know it, right? It doesn't mean that you have to learn a lot of new things in school. Rather, it means that you have to be open-minded and flexible about the things that you don't know yet, because it's all about customer concern first and foremost and offering better value to your customers.
So hire people who are open-minded and flexible and willing to get into new tech and not intimidated by it.
Absolutely.
Brilliant. That would be the last words for this episode. I am so grateful that you wanted to be on the show today. This is an important topic, and it's kind of challenging to penetrate. And certainly, if you're a leader working in a cloud project, you need to understand about this topic. So I'm thankful that you wanted to join today for the Cloud Show.
It was a pleasure, Magnus. Thank you so much for having me.
Perfect. Have a great evening, everyone.